Yeah, looks like we're live. Um, Perfect. Hello, everyone. Welcome to the workshop series of Hack AVS. We opened the hackathon yesterday with a lot of partners, with a lot of judges, and definitely there was a bit of overload in terms of the information shared. But like I said yesterday, and also throwing light on it today, that do not feel overwhelmed in the process because we actually have workshop series with all the partners that we have, everyone who's sponsoring a bounty, and even we're also happy to connect you with the mentors. We're kicking off the first workshop for the entire hackathon series with Brevis, which is a ZK coprocessor on eigenlayer. Definitely one of the hottest theme on eigenlayer out there. I'd love to welcome Junda today, who's the co-founder at Brevis. Maybe Junda, you can start from any opening words that you have for the hackers who will be building in this hackathon. Definitely, they would need a lot of context because this is a comparatively new ecosystem. So feel free to take on the stage and then hop on to the presentation that you have for them today.
Thank you, Michika. Thanks. Yeah. So I assume there are many more people on the other side of the screen. I'm just talking to my laptop. Thank you and welcome. Yeah, it's really great. It's a great pleasure, and we are sponsoring the DoraHacks, and also we are one of the first official, mainnet AVS launch partners on EigenLayer. And if you check their dashboard right now, I think we by the number of risk-take amount or some other metrics, we are right behind EigenDA. So we are number two since the launch. So it has been a very good trajectory. And we are, of course, onboarding more and more operators to help, keep securing the network. And on the other side, right, because as Michelle mentioned, the whole ZK coprocessor is relatively, new, unlike like roll-up layer 2 everyone has been familiar with. So I was saying the first part of my talk is more to make sure, people get the idea, say, yes, of course, ZK coprocessor makes perfect sense. And it is one, the way to go. And the second part will focus more on, say, hey, if you kind of are convinced that this is a good idea, and how do you like really leverage, like especially using Brevis SDK and the whole support system Brevis provides, like to make your dApp much more, I would say, feature rich and more capable than the traditional, dApp smart contract on a blockchain. Okay, let's start. So after, I would say, so many years, we have seen tremendous improvement over both performance, usability, and even programming models on blockchain, right? So, but there's something fundamental that we cannot easily overcome. It's the high cost associated from the global, the decentralized consensus, right? Because you have, no matter it's POW or POS or any other POX, right, mechanism, you need the thousands or even tens of thousands machines on the internet to agree on something. So that's how kind of put a fundamental limit on the blockchain. Right? Yes, we have layer 2 now. We have like all the roll ups or even layer 3, but every time you go into the 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 chain and also the programming model, you realize it's very restricted, right? For people who have experience with Solidity, you kind of immediately know what I'm talking about, because what can you do in Solidity, right? If you think about it, it's very limited compared to like traditional programming languages. That might be kind of a high level thing, and let's go through a concrete example. For any centralized exchanges, since day one, they have to have something called a trader loyalty program. It's basically, on the simplest term, to give bigger traders either a fee discount or fee rebate, or kind of a form of incentive to keep the traders stay within their system, right? But until, I would say, 1 or 2 months ago, none of the DEX has it. Why? If you think about a simple example, on the high level, you have a very simple requirement. You say, I want to know, say some big traders, right? They have done 10,000 trades in the past 30 days. I want to know their total trading volume. And based on the trading volume, I want to like give them a different VIP tiers, like gold, silver, platinum, diamond, whatever, and then give them a different fee rebate. Right? It's a very I would say intuitive and makes perfect sense, but the DEX couldn't have it because if you think about how can you do that purely on chain, which is surprisingly, I would say unsurprisingly expensive and prohibitively expensive. Of course, people say, hey, EVM at least is supposed to be a Turing complete. You should be able to do arbitrary any computation possible, right? But that only happens in theory, because if you look at what you need to do, you have to remember the state roots for I would say 10,000 blocks, and then you have to calculate the 10,000 Merkle proofs of the transaction inclusion on chain, right, inside your Solidity smart contract. And next, don't forget, it's never designed to be, when they design the underlying data structure of Ethereum, like if you go into the internal of the world state, they use RLP encoding everywhere, and it's never designed to be efficient. So that's a fun part, right? It's supposed to be the building blocks, the fundamental building blocks for everything Ethereum, and if you look at it, it's not efficient at all. And then for the transactions, you have to do the RLP decoding to understand what's actually in there. Right? And the last, you do remember we want to have the total trading volume. So we need to do a simple sum, basically the aggregation of the trading volume. And we actually did some like a back of the envelope calculation. Of course, no one even tried to do that actually on the blockchain, right? It doesn't matter if it's layer 1 or layer 2. The cost is crazy, right? It's like you are literally, if you want to really do that, yes, in theory, you can write a Solidity contract, ignoring the block gas limit, right? Now they have, I think, 11 million or something. You say, ignore the gas limit. How can I do that? The total computation easily need like a continuous 4 hours of Ethereum blocks, right? And who knows how much fee you need to pay, right? So that's kind of try to give, I know people are, the dApp developer already have the context. When you come into the field, you already know, oh, there are so many things I cannot do, right? So basically you are trained to say, oh, there's a very small scope and I just live within this scope, and there are still amazing applications that can be developed, but it's still, right, remember, Solidity has no access to history, right? It's like you are writing an application without access to a database, right? That sounds like unimaginable before, but now people actually are comfortable with that. Yeah, there's no history. What's the big deal? But if you talk to anyone from other programming field, they were basically considered as a crazy, right? It's just unimaginable. So that's why, kind of just like how GPUs offload the more computing intensive tasks from the CPU. Right? Today, GPU, maybe a few years back, people talk more for graphics, but today everyone talks about AI, right? And the GPU is one of the most well-known coprocessor. And we are arguing that blockchains also need a coprocessor to offload those data-rich and complex computations, right? So basically, you will still have your transactional computation, like more for deterministic order, which the blockchain is good at. And then you offload those, heavy data analytics or even more, machine learning tasks into a coprocessor that runs on ZK. And after the computation and the data analytic is done, the coprocessor will post a final result on the blockchain. The number one thing we want to emphasize is the whole thing why we say ZK coprocessor instead of any other coprocessor is we're not compromising the trust-free nature of blockchain. So basically, by introducing the ZK coprocessor, we're not introducing another third-party committee or whatever you need to trust, right? So because when we show this, many people may ask, oh, don't we already have like Dune or something similar? If you think about that, right? So whenever people query those proprietary APIs, you are putting a trust on their private database, their code and their API give you the right result, right? And another key, I would say, barrier to adoption is for non-ZK off-chain data and analytics and dashboards. We have them, but there is no action on chain, right? You can do whatever fancy dashboards, show them in the browser, but your dApp that runs on the blockchain cannot benefit from those insights, right? To say you do know, oh, of course they have Dune dashboards for big traders, but what can you do about them, right? So that this address has done a lot in the past 30 days, but your on-chain contract, how do they benefit from this result? With those model, it simply doesn't work. Now let's talk about Brevis. Of course, in the field there are more and more coprocessor projects. Of course, we are the first ones out there, and even some projects previously didn't. They kind of see this great opportunity and they rebrand them as ZK Coprocessor. So I want to focus on the high level. People are doing similar things. Like Brevis generate a ZK proof of arbitrary computation on any data. Right now, in the first wave, first launch, it's more focused on the historical on-chain data. But there's never a say, oh, we can only do historical on-chain data. We can do anything that can be ZK proved, ZK verified. And the second part is we utilize the computation results on-chain in the trust-free way. That's why we emphasize this whole trust-free again. There's no third-party committee or anything else you need to trust. You only need to trust the underlying math and the code, right? So this is just the same as any blockchain projects. So there are 3 simple steps because I will kind of now we move on to if you are a dApp developer and you are convinced, say yes, I really want my dApp to be less dumb than before, right? We'll keep joking. The smart contract is not smart at all. It's actually pretty dumb. It can only see what's at that block, what's available at that block, and we can only talk to other contracts through predefined interface. So there are all those kind of unnecessary restrictions. With ZK coprocessor, we can overcome all of them. Right? The first step is read. Basically, you as a developer, you need to know what are it could be historical, it could be more recent, but it doesn't matter. What are the data you are interested in, right? It could be ERC20 balance, right? Or when the user has the first NFT, right? So all those kind of already available, publicly available for everyone else, like Dune, and they also kind of go to query all this kind of data, right? So for any blockchain that we can support, and it's quite often our partners come to us and say, hey, we want to launch on this mainnet, like I think Trust Labs on Linea. We say sure. We spin up a new infrastructure to kind of verify the consensus part, and then the partner can run their own logic right against any chain, because the ZK coprocessor by definition doesn't belong to any chain, right? As long as it can read the chain data state and all the information that it needs and generate proof, it's fine. And using our right now our most production ready SDK is written in Go. I will explain a little bit more later why we went this way. And the API actually hides all the underlying ZK complexity and basically let the developer to express their intent. So basically, you say, I know this is the risk. Like we go back to the trading volume example, right? So it actually shows what's the volume for each swap or trade is actually in the event. So basically, you say, I know it's in the receipt, and this is the receipt field, the event field I'm interested in, right? And I will be interested the amount, the recipient, basically who gets this money, and also the sender, as basically the who initiates the swap, right? And this actually is just simply what the developer need to write, to basically prepare the whole system. Say, hey, these are the data points, and I'm interested. It could be transaction, receipt, storage value, and anything that on the blockchain. And the next step is compute, right? So remember, we say, hey, for the simple example we talk about, we need to compute a sum, right? Basically, aggregation of the volume. And we realize, hey, it's more and more feeling like a data analytic task. So we literally add a MapReduce style API. So basically, instead of you write your own like loop, like to say, oh, I'm writing from I equals 0, blah, 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 to the total number of receipts, add up the swap volume account, right? Amount together. Instead of that, you can see here we have more MapReduce style. You just write sum over a function, and that's it. So that's kind of the thing. Of course, we have down the road, we have even more UDF support and machine learning friendly APIs in the pipeline. So we kind of recognize the applications or partners try to work with us really, looks more like traditional data analytics or machine learning application, less for the what we call today's dApp, right? So basically, they will be very data rich and heavy computation. So we kind of expose the API instead of the low level. Oh, you do everything by yourself. We recognize this need, and we provide this high level style that allow them to do like more freely to express, and also the code is more concise and express the intent more clearly. Right? So that's the power of the high level APIs. And of course, down inside the SDK is all the hard work done from the Brevis Eng team that translating into ZK circuit. So basically, the developer is still writing a ZK circuit, but they don't feel like they are doing that because there is no which prime field to choose, what curve, and how do you do this entity mass, right? So none of that, all of that is already handled inside the Brevis SDK. And the API is simply say, hey, just tell me what you want to do, what you want to achieve as the computation. And finally, remember, with the ZK verify result, right? After the whole thing runs and the Brevis the prover networks generate the proof, and we submit to the Brevis core contract and verify, yes, this ZK proof is valid and verified and met corresponding to the developer's circuit, then the core contract will simply send a callback, not callback, but it's more like a cross contract call to notify the developer's contract that, hey, here's the result. And this is just the only interface you need to implement in your Solidity contract. Handle proof result. Right? It's also, the name is very self-explanatory. Right? I don't even need to say more work. So whatever, in your circuit or whatever, what we call the Brevis off-chain, the ZK app, right? In your app, you do some computation and return some results, right? Like in the example, we have the total volume and block number and blah blah blah, and then whatever result is generated from your circuit will be verified from Brevis core contract and then hand over to your contract as a result. Right? So your smart contract doesn't deal with the proof because it's already verified by the smart contract of Brevis deployed, and then you only need to deal with the result and a simple decode, and you can do whatever you need, right? Like back to the Uniswap example earlier, this is where they will assign different VIP status to based on the volume, right? It's just very simple logic. Okay, so we do get this question, say why the SDK is written in Go, right? And why is not any ZK VM or any other language? The the simple answer is the scale, right? So we as a project, we talk with many. We already have partnerships with many of the leading projects in DeFi, in ZKML, and in many other fields. And the number one thing they care about is, yes, is this even possible, right? Say I have thousands of, let's just call it data points. Right? It could be transaction, receipt, or storage, or whatever. I have thousands of them. Can you handle them? How long do I need to wait to get this proof? Right? Remember, ZK is still a very expensive thing. Right? And so the Brevis is production ready. So not just hand waving say we are production ready. We actually already had mainnet launch a pure ZK mode 2 months ago, and the hybrid eigenlayer AVS launch during the ZK summit in Athens. It's about 3 weeks ago, right? Almost a month now. So we have our production infrastructure out there to squeeze, the last bit of even 1% of the performance we can get. So that's why, we kind of went with this more down to the bottom. We handcrafted the most efficient underlying, component circuits. And so the developer or our partners can benefit from the scale and the performance, and also it translates to cost saving, right? So this is the number we run on, really, because we launched with Uniswap. This is the number, right? And this actually for the traders, they are more than willing to pay for this, right? Remember, for the proof, they even said pay 10 or even $50 for that. They can claim hundreds or even thousands of dollars in fee rebate. Right? So that's kind of a no-brainer for that. And we have talked a lot, and you might be wondering, where is AVS? Why you launch with Eigen, right? The pure ZK mode sounds perfect. Yes, except there's one thing. ZK actually has its big limitation. The ZK is perfect. It's very good at proving something exists. So you say, yes, prove I did this, prove my trading volume, right? So all of that it's actually good. And ZK is very good at it. But ZK sucks if you try to prove something didn't happen. We literally have, our production launched partners came to us and say, hey, can you prove this address didn't use Tornado Cash before? Prove something didn't happen in ZK, world, had to prove something opposite. So basically, you either prove all the addresses have used Tornado Cash and say, yes, this address is not included in this set. Or you say, I will go through every single transaction this address has sent, right? It's, fundamentally unbounded, right? It could be literally millions of the transactions from the address. And you go one by one and say, look, it's not Tornado Cash. Both solutions would never, fly. Right? It's just too expensive. So that's why we feel the power to combine the crypto economics and the ZK as the final, settlement. So here is the thing, right? Back to the Tornado Cash example. Instead of trying to prove something didn't happen, we ask a network of operators to say, hey, what's your opinion on this result, right? So if they check the history and they say, oh, yeah, we agree, like 2/3 of the vote say, yes, this address didn't use Tornado Cash before. And they can co-sign a result, right? Basically post it on chain. Say, yeah, this is the consensus from this, the network of operators. You might say, hey, wait a second. Didn't you say we never introduce additional trust assumption, right? Yes, we didn't, because we don't have to trust this 2/3 of the voted result. Anyone can watch this thing on chain, just like a watcher or monitoring, like a watchtower. People give them different names, like a optimistic roll up, right? So anyone can watch the thing, and if they disagree, they say, hey, the operators are not telling the truth. I can't find that single transaction that that this address did interact with Tornado Cache before. So the challenger only need to send a single transaction ZK proof, which today is so easy you can literally do within your browser, right? So that's kind of nothing to worry about as from the cost perspective. And the challenger has all the incentive aligned because they are more than willing to generate this proof and submit on chain because they know they can get the slashed stake token as a reward. So basically, we also solve the who is paying for the proving cost problem, right? So I think this is kind of the only Brevis is the only hybrid ZK coprocessor. We had the pure ZK mode for some of the partners. We actually launched that first on mainnet, on different mainnet, right? Ethereum, Linear, Arbitrum, whatever, and based on the partner's requirement. And then we are the first and only hybrid coprocessor. We combine the ZK economics, the crypto economics, and the ZK guarantee. So basically, we don't have to trust the committee is honest. It doesn't matter. As long as there are a single person see, oh, there is so much staked token as a reward, I will generate this proof and post it on chain to prove all of them wrong. So with this hybrid mode, not only we significantly expand the use cases we can support, right? Remember, the pure ZK, none of them can tell you this address didn't do something, only with the hybrid mode, right? And again, the good part is from a developer perspective, you don't even see the difference. The API doesn't change at all. You don't have to say, oh, what am I doing? The only difference is when you when the user initiates the request on chain, the developer will say, hey, I'm using pure ZK mode or I'm using the hybrid mode, right? So basically, with the hybrid mode, there is another, I would say, benefit for the user because said the operators are most of the time honest. We do not incur the ZK proving cost. So from the user's perspective, especially for some low value, like we talk about Uniswap VIP trader, but then there's also this like random airdrop, right? They initially they said we will never use a ZK coprocessor because the cost is 10 times higher, no matter how you do, right? Even it's $1, it's 10 times higher than the airdrop tokens. I don't want to do it, but now they can because it's just the good path, right? It's just a traditional multi-sig. Of course, we are the eigenlayer AVS. We just leverage whatever the existing eigenlayer infrastructure. So with Brevis AVS, which launched on Ethereum mainnet 3 weeks ago, actually, yeah, 3 weeks ago. The user can submit a request and say this is the hybrid model. Basically, they will go with the optimistic, basically the cosine multi-sig path first. And if there is a challenge, the ZK challenger will overwrite the result. Right? So basically say, no, that's the wrong result. The ZK is the correct result. And then the challenger gets the reward of the slash token. That actually comes later because eigenlayer itself doesn't support slashing yet. And on the other side, the user gets significantly lower, normal operation cost because they don't have to pay for every request a ZK proving price. Okay, I think that's pretty much it. The next few slides is more like, I don't know if it's needed or not, but kind of different ideas. We have talked with different partners. Of course, the data-driven DeFi is more intelligent DeFi. It's basically a DeFi finally has a database, right? It sounds silly, but it's actually true. And like in the beginning, why I said it's only up to like 2 months ago, because 2 months ago we launched this with Uniswap, right? And also, of course, the ZK reputation, ZK DID, and everything related with that, we launched with Trust Labs. There, of course, with the power of trust-free historical data access and arbitrary computation, I would say it's only limited by the developer's imagination of what kind of new use cases you can think about. And with Trust Labs, we launched I think it's on Linear mainnet. They basically compute a credit score, right, for each address. And this is kind of is the power we see. Oh, now we can really, many people say, oh, the history is a gold mine, right? It's just like data out there is just waiting for people to really take a look and generate insight. And I think it's up until now we finally have a good way not only have the insight but also take action within the smart contract. And yeah, more on our blog you can just follow our Twitter and check our blog posts and also our documentation for developers. The ZKML is another big thing. Kind of, we already had a very successful hackathon projects in East Denver. Right? They did a machine learning based option trading model and runs on Brevis, and that's actually very impressive. Within, I would say, 3-4 days, they not only get the whole Brevis flow working end to end, and also they can port their machine learning model into the code. I think that's kind of another attestation to say the API is indeed easy to use and develop. Right? And if you have any question, join our Discord to ask. Right? Yeah, and that's it. That's all from my side. Thank you, everyone.
Yeah, thanks a lot, Junda. I think that was super helpful, especially, wherein you came in and gave some use cases and examples of what the developers can build throughout this hackathon. Just something that I would like to ask on the behalf of everyone watching, what should be the right place for the builders to go and talk whenever they're stuck with any question or, whenever they want to ask anything?
Yeah, I would say still join our Discord. Discord is, we do have, our Eng team monitoring that, and just, I would just make sure to give them a heads up. So yeah, if we see developers asking question, we'll, give them a timely response. Yeah.
Got it, got it. That's super helpful. But for everyone watching today, you will still have, if you want to revisit anything from the workshop, you will still have this workshop on the workshop tab on the Hack AVS Hackathon page. So feel free to revisit any part that you might want to dive deep in, and yeah, feel also free to get in contact with the team if you want help with anything throughout the hackathon. And yeah, I'm wishing everyone good luck. Junda, in case you want to share any words of motivation for everyone hacking in this hackathon.
Oh, the words for inspiration. That's good. Good. That, I would say many great projects were born from hackathon, right? So, and I think we are particularly excited about the whole ZK coprocessor is because unlike the layer 2 rollup, we are no longer in the scaling game, right? If you think about that, right, it's a completely a new paradigm for applications. So that's why we are super excited, and we cannot wait to see all the great application the developers can write. Yeah.
Perfect. With that, I'd love to thank everyone who joined us today, and especially Junda for coming up with such a great um, immersive presentation. Yeah,
Thank you.
thanks a lot, everyone. And I wish everyone all the best to build in this hackathon. Yeah, keep building and breaking.
Okay.
Yeah.
Good luck.
Thank you so much for joining. Take care, everyone. Bye bye.
Bye.